Today I'll be presenting Journey to Massive Regression. Just a disclaimer, this PDF is a little messed up, I will be attaching the accompanying RMD file. Um, the single most important concept for me in regression analysis is probably the Bayes variance trade-off, which is shown in the variant estimators for the coefficients. The OLS estimator is an unbiased estimator, whereas ridge regression is biased. However, it results in a lower variance of these estimates. My understanding has evolved throughout this course of this idea as when we started with SLR, UPR, MLR, I thought that the method of estimation for those coefficients was just a default and there was no other way. However, once we got to more high dimensional data with increasing issues of multilinearity, I realized that the ridge regression estimator might be the best method for these. A key insight from the theory I found has to do with the conditional expectation of variances. The conditional expectations for both the actual expectation and the estimate is the same, meaning that the estimate expectation is an unbiased estimator of the actual expectation. However, this is not the same for the variances, and we can see here that the actual variance does not rely on xi. However, the estimate actually does rely on xi, as you can see right here. Because of this, we can say that there's less noise in the fitted values, and that the estimated variance of the fitted values in the estimate should be less than the actual variance. A surprising finding from my applied work had to do with the mirage, and that the results for BIC and AIC were essentially completely different. BIC was very strict, and there were no predictors in that model. And as we can see from best subsets, the most used model had zero predictors. However, when we went to use AIC to run the simulation 10 times, a significant model was used pretty much every single time, meaning that at least one predictor was deemed significant. Increased complexity can be an issue for researchers, as it can be essentially impossible to interpret what the true model is. A champion model won an arena because it included the most important data. Excuse me for 1 second. It included the most important data which we use in the AIC model, and it contained the most important variables for this model, despite the higher complexity compared to BIC and BMS. And it was clear with those that they were too simple and they left out important estimators that would greatly capture and explain the data. As you will see, the adjusted R-squared value for AIC should be greater than it for BIC. The most challenging unconquered peak that I still have has to be still the matrix calculations and the theory. It has definitely improved over the semester. However, I'd say for this one I struggled a lot. I had to use a lot of the notes and the information in the textbook, as well as a little bit of refreshers of linear algebra using AI. And the R code for this assignment as well I found very difficult. Usually I have a strong grasp of the code and how to efficiently find the correct data. However, this one I'll say I heavily struggle with it. And for some of the data, I'm not exactly sure if it's all correct. Something I found the most fun, what I found the most fun in regression is stepwise regression stepwise selection and best subsets. This is apparent in exercise all throughout all exercise one as I completed this pretty swiftly, and I believe I have the greatest grasp of information in this specific exercise. In this specific exercise compared to all the other exercises. I expect a score on this assignment of I believe around a C plus, maybe B minus. I like I said, I significantly struggled with this assignment. I was unsure of a lot of things. It's my fault. I should have asked for my own help. I should have asked for some help. And I went to office hours. However, I want to see if I can do this myself. Obviously, I still need some more time to grasp some of the concepts and more practice of these concepts. Regression has changed how I see data in the world, as I believe now every event and phenomenon can be explained through data analysis and machine learning. And I believe that data is significantly more complex than most people would think at the naked eye level.